Okay, guys, so sorry it cut me off. This program I'm using only gives me limited time. So let's get back to it. So let's review. Since you won't have line generators in different colors, let's just talk about how you can best do this on your test. So I'm still going to use different colors so you can see, but this is what I suggest you do. So I can't remember the equation. If it was 2, um, let's just say it was 2 comma 3, um, let's say that was the point. Okay, so um, so I would do this. I would there's two different ways. Again, we did this. You could draw. I suggest drawing a line out this many spaces on the positive x-axis, or on the x-axis. Since this is a positive 3 in the y position, I would draw out a line out along the y-axis to 3, and then I would draw a line up, in this case up 4, 1, 2, 3, 4, up the z-axis, and then I would go to town making parallel lines from the ends of each of those. So what I mean by parallel lines is here's the x segment. We'll come out to the end of the y segment and draw a parallel line just the same as you did for the x. Come up to this z endpoint and draw a parallel line just the same as you did for this x. Now there's going to be another one floating out right here, so I can either draw that now or I'll wait. But you could, once you're good at it, you can draw it right now floating up in space. But let's draw these others first. So here's your y line. Come straight up and draw a horizontal y line parallel and the same length as that guy. Okay, come down here to the end of the x and shoot one over. That's supposed to be straight, but still trying to get used to this pen. So connect those endpoints and do another one just like the one you just did, straight over, and end it right above this guy. Okay, well, here's the z segment. Come down to the end of the x again and draw a vertical line connecting these endpoints. Connect these endpoints. Connect these endpoints. And you'll see now there's that one that we haven't drawn yet, but you would just connect those points. Notice the blue, there's 4 parallel segments there, all the same as this X segment. There are 4 parallel red lines, just like this red Y segment. 1, 2, 3, 4. And there are 4 parallel vertical green lines, just like the original Z segment. And that way, this here is your point right out here. It's out 2, to the right 3, and up 4 from the origin. And there's your point floating in space. Now once you get good at it, you can just start doing that. From the origin, come out 2, shoot to the right roughly 3, about here. Remember, there's that parallel blue line right there. And you can shoot up a length of 4, roughly about, up here. And that point is dancing in the middle of space, just like shown here. Okay? So, but I suggest doing the box, and that shows me that you understand the concept as well. Coming out here is here. This blue guy is parallel to him, and look at this. This is parallel to this guy, and this guy, and look at this. Ooh, he's parallel to him. if I could draw correctly, parallel to him, and finally, voila. That horrible, horrible. Trying to get used to this stylus. It's weird. It's weird drawing on a computer thing. Okay, so that's that. Hopefully that helps. Draw your magic box. 4 parallel lines, 4 parallel lines, 4 parallel diagonal lines, and you have your point floating in space. Let's talk about the other quadrants now. We've thoroughly talked about this first quadrant. I'm sorry, I say quadrant, I mean octant. There are 8 octants, and this is the first one where it's positive x, positive y, and positive z. The second octant is back behind it, right over here, in this orange area, but behind this blue wall right here. And so that's a negative x, but it's still a positive y and a positive z. And back way in the corner here is the third octant. You can imagine that's negative x. Now it's negative y, but still a positive z. All of these up top here are going to be positive z's. And here's the fourth octant over here, which is now a positive x, but a negative y, but still the positive z, just like everything on top. Another thing that bothers me, why they rearrange this x and y and the z, is because if you look at it, come up here, put your head up here and look straight down, orient your legs over here, and so your head's here, your legs are here. You're looking down, and again, the x would be coming to your right, and the y would be going up, and the z would be poking you in the nose. Well, look, it's just the same as the quadrants. First quadrant, second quadrant, third quadrant, and fourth quadrant. It goes counterclockwise. So again, it would have been nice if they would have been consistent and kept it. And some people do. You know, you search the web, and a lot of people, you know, orient the x over here, the y up here, and the z coming out. But so just be aware of that. So okay, let's continue on. Then this is the fifth octant, the sixth octant, tacked way, I don't know how to write it, back there, the seventh, oh, I'm sorry, shoot, the seventh octant is tucked back behind there, and then this is the 8th octant right here. Going through briefly, all these z's are going to be negative. This will be positive x, positive y, negative z, negative x, positive y, negative z. So it'd be negative x, negative y, negative z, and the 8 right here then would be positive, negative, and negative. So this could be, you know, quick test questions. Which octant would be, you know, positive, negative, positive for x, y, and z, and you would say the fourth octant, or something to that effect. Does that make sense? Okay, so be familiar with this three-dimensional spatial reasoning. Okay, moving on. Now we're going to continue. Now we're going to graph linear equations in 3 variables. Before we were plotting a coordinate. We were plotting points in 3 dimensions. Okay, this is plotting points in 3 dimensions. Well, now we're going to actually graph a linear equation in 3 dimensions and see how that's different. Well, and so, okay. a linear equation. In two variables, a linear equation is, you know, it's of the form ax plus by equals c, and the graph of it, you know, the graph of an equation is the graph of all of its solutions, right? All of its solutions. So in two variables, it graphs a line at two dimensions, okay? Well, in three variables, can you imagine, even though it's called a linear equation in three variables, and the pattern is ax plus by plus cz equals d, the graph of it is actually a plane. Even though it says linear equation in three variables, the graph is a plane. And this is how you go about doing it. So let's say we have the equation 3x plus 2y plus 4z equals 12. Well, just like with two variables, we would just, come on. Hello? Berg. Okay, just like with two variables, if we came and plugged in 0 for x, we could solve for y. Well, if we plug in 0 for x and y, then in this case we can solve for z. Z would equal 3. And that's when x is 0, y is 0, but z is 3. We can place that dot. Well, let's continue on. If x is 0 and z is 0, then y would equal 6. We would come out 1, 2, 3, 4, 5, 6, plot that dot. And if we plug in zeros then for y and for z, then x would equal 4. We can come out 1, 2, 3, 4 and place that dot. Now here's how you do it. Again, we said the graph of this guy is a plane, as you can imagine, 3 dimensions, and so well, let's see, can I do a line here? Okay, good. So it's somewhat straight. There we go. And I don't know why that's not erasing. Okay. There we go. And then we'll go. Why does it keep doing that? There. And we'll just connect those dots. And if we connect those dots, that represents the plane. Let's see if I can kind of make it what color you want. Let's just go green. Okay, let's see if I can kind of shade in roughly this plane. And that is the plane kind of slicing through. It goes on all directions, of course. It's not just a little triangle, but it represents the plane of this line right here. That's how we graph it. Just plot your 3 dots, your 3 intercepts, okay? 3 axis intercepts, and connect those dots. It's just that easy. I'll see you in the next video.